In today's video, I'm going to show you how to implement your own linked list from scratch. So a linked list is an abstract data structure with nodes. And basically, what do I mean nodes? Or specifically what this data structure is. So specifically, a linked list is of course consisted of several nodes. So node, and then node, and then node, and then of course all the way until null right here, in which case there is no node. So the element that points to null is going to be the last element of the linked list. But what will the nodes contain? They contain some sort of data. So of course each node that is not null will have some sort of data. So we're going to make our very own linked list. So we're going to create a node class because of course we need nodes in order to get this linked list started. So what will the nodes contain? So we need data. We're going to make this public object data. And if you know from inner classes, if you mean, we usually use public so we can access the method or fields inside the linked list class, or inside the outer class, basically. So, and then we do public node next. And now for a constructor, which will take in a parameter for the data. And of course, we need to do this.data equals data, because this.data refers to the instance variable, and the data refers to the parameter data. So of course, we're going to add a toString as well. So we're going to return the data, plus we're going to add a space and an arrow and a space as well. Now the main reason we're using an arrow is to show that a node is pointing to another node. So that's going to be why we have this arrow. And also we can know that this is the last element of the linked list. So now we're going to make our very own linked list class. So first of all, we need a head and a tail. So the main reason we're going to do this is so that we can make this a singly linked list or a doubly linked list. We're first working on a singly linked list because we have the next pointer. And the main reason I included a head and a tail is so that adding and removing elements can be easier. So we're actually going to do AddFirst, and then we're going to do RemoveLast. Because this is how queues usually work. So you can usually add first and remove last, or you can add last and remove first. In this case, I'm going to do add first. And we need something to add to the linked list. So we're using an element. We don't want the whole node, otherwise we're going to have to make a new object here. And we can make a new object inside the method body anyway. So we're going to make new node taking the element. And that's why we're making this new node. So first of all, we need to make sure that we add an element correctly. So the first thing we want to look for is if the linked list is currently empty. In which case, if you create a new linked list, the linked list is going to be empty anyway. So if you do an if statement, that will be head equals null. And basically, if the linked list is empty, you won't have a head or a tail. And you don't even need to check if the tail is null anyway, because if the head is null, if there is a tail, I should say, there also has to be a head. So of course, we're going to go ahead and do head equals new node. And then head.next is going to be null, of course. Otherwise, we need that else statement here because this is a void method. So otherwise, if we already have a head or tail, we're just using the head here. So we want to set the new node's reference to the next node in the linked list here. Or specifically, or like specifically the head, I should say. So of course we say new node dot next equals head, and then we want to do head equals new node. And basically what we're doing is we're saying the new node dot next, the pointer will lead to the current head, and then the head will be reassigned to the new node. So after this, we're going to remove last. So public void remove last. And we should consider our condition as well. So if the head is equivalent to the tail, then the head should be equivalent to null. Otherwise, we simply have to get rid of the reference. However, we only have a head and a tail, and a next. We don't have a previous. Node in a single linked list. So you have to use a counter node and use the while loop to traverse the nodes. So we're going to do node iterator. Let's call this an iterator. Equals new node. Actually, never mind. This will be the head of the linked list. Basically the first element. So while we're going to say iterator dot next is not equivalent to the current tail, I should say. So of course we're going to do iterator equals iterator dot next, and basically we're pointing the iterator to the next node and then assigning it the iterator variable. So of course, now that iterator is basically the element before the tail, we simply can just remove the reference. We can simply remove the next reference from the iterator. So we do iterator dot next is going to be equivalent to null, but that means the tail will also be null. So we have to set the tail equals iterator if we want to remove last. So now we're going to go ahead and create a display method. In this case, we want to display all the elements of the linked list. We already have a toString from the node class. So we can of course use the display in the linked list here. So we're using a while loop here. Well, actually, let's make the toString. Let's make it a toString. We don't need a display. So we're actually going to go ahead and do return this for now. We're just using an accumulator to store all the elements. So string ACC, I called it ACC, short for accumulator. And basically, once we traverse all the nodes, we're going to add the contents, or add the data, or basically I should say the data from each node into the accumulator. And now of course we need an iterator node as well. So node iterator equals head, and then we do while the iterator is not equivalent to null, because of course the last element is basically the last non-null element of the linked list. And once iterator is null, we're finished with the linked list. So iterator equals iterator dot next, and that's basically moving the position of the nodes, not moving the position. It's not modifying the list in any way. But anyway, we have to add the data to the accumulator. So ACC plus equals, we have the iterator.data. Iterator.data. So now of course we're going to return ACC. And then we should worry about displaying the linked list. So we're going to add the main method inside, and I called this linked lists. So of course I'm going to call this linked list as well. So we're going to go ahead and of course, you do new linked lists, which of course we have no constructor actually. And considering that, I actually forgot the constructor in the node class, in the linked list class, I mean. So, initially they will be null anyway. So head is null, and tail is null. So this will actually be linked lists, not linked list. I actually got the casing wrong. So I did end up forgetting the constructor. So we're going to do linked list dot head, not head. So linked list dot add first. And then we want to add something such as like 68, and of course we want to add different data types as well. So we're going to add 87, 24, 94. I know I said different data types, but I'm just using integers for now. We're going to add first. Now we're going to display the linked list. Well, I'm actually going to display the linked list for every addition or removal we're going to do. So, linked list, I'll remove last. And now, we're just going to remove the last two that we do. So this is a very large main method, not gonna lie. But after this, we want to, of course, display this. So, of course, this looks very unorganized, though, since we don't have any spaces. Well, actually, because we actually used iterator.data, we actually need to use iterator. And the iterator will look much clean. Here we go. There we go. So now, this is basically part of our linked list implementation. So I didn't actually use indices just yet. So this is typically how linked lists would be used in a queue. I'll be discussing how they're used in lists later, but stay tuned for that, because the next video is going to talk about the day queue methods as well, and how linked lists can be used as a stack and a dick. And of course, see you guys later. Goodbye.